Okay, so what we're going to do in this chapter is we're going to look at actually modeling something with polys. And this is in earnest in this case. So we're actually going to use the tools to create something which is a little bit more complex. And what I've actually gone for is a go-kart design, which I found on the internet, which was actually public domain, i.e. it didn't have any copyright on it. And what I've actually done is I've based this frame that you can see here on that design, and I've made up this guide. This isn't actually meant to be the final model. This is the guide model, which will allow us to actually build our poly model. Now, this was actually on an American website, so all the measurements are in imperial. And for instance, I'm British, and in the UK these days we use metric. And most computer software actually works in a metric system as well. For instance, all of these units are based on units of 10, so it's a metricized system. So what I've done is I've worked out the difference between an inch and a centimeter, and basically for every inch you get 2.54 centimeters, and I'm using that as the basis of this model. So in other words, one unit in our model is equal to 1 centimeter, so that means that every inch is equal to 2.54 units. Let me just hide the grid actually, just to make it a bit clear what's going on. This cube is 1 inch squared, so it's 2.54, 2.54, 2.54. And I then moved it a random kind of distance over to here, and I created this cube next. And based on the design, I found out that the length of this beam here in the go-kart's frame was 91.44 centimeters long. So I just basically just put that dimension in here. Then I went to one of these cross beams and I found out that this was 44.45 centimeters. And I aligned it to the center of the grid, as you can see here. And it's important to note that this frame is completely symmetrical, so we're actually going to use that whilst we're modeling. So let's have a look at the grid again. And as you can see, there's a central line of symmetry down the middle of this frame. So that means we only really have to model one half of the frame, and then we can mirror that across and use that as the other side. And this is a common technique when people model, especially mechanical objects. There's usually a lot of symmetry involved. So really, you only really have to model one half of the object, and then you can mirror it over to the other side. There may be unique features, but then you can add those as a final stage to your modeling process. So based on the design, I laid out all of these cubes, and as you can see, it gives you a rough approximation of what the frame should look like. And it's not completely accurate, but it'll do for our purposes. Now, in the real design, the tube is actually beveled. It has rounded corners, but these are actually mathematically perfect cubes, so they won't actually shade so well when we're rendering. So what I'm going to do in the final design as well is actually show you how to bevel the final model. That will give you better results when you actually render it. So in preparation for the modeling process, let's just zoom out here, and I'll show you the next stage of our modeling process here. So the first thing that we'll do is we'll rename all the objects in this scene. We just get rid of this little object here. And I'm going to rename everything so it makes it obvious what these parts are meant to be used for. And I'm going to use the Tools Rename Objects tool. I'm going to give it a base name of, let's call it frame, let's go guide. I'm going to use a prefix of geo to indicate that it's geometry. I'm going to use a suffix, in other words, what comes after the name, of underscore. That'll just put a space, well, an underscore between the name and what comes next. And I'm going to make it numbered. I'm going to click on rename. And if I go up to the list here, you can see that it's actually renamed everything. So it now has the name geo underscore frame guide and underscore number. And that gives everything a unique name, which makes sense. Then what I'm going to do is I'm actually going to put this into a layer using the layer system in 3ds Max. Just open up the layer window here by clicking on this icon. But what I want to do also is to control the visibility of this using the layers values rather than the values used in the viewport. I can set it to wireframe in the viewport. I can set it to facets, shaded, whatever. But I actually want to control that display using layers. So to do that, I need to right click on these objects, which I have selected. go down to properties, and in the display properties, I want them to be controlled by layer rather than by object. I'm just going to OK that. Now I'm going to create a new layer, and everything that I have selected gets put into that layer. I'm going to call this frame guide. And now if I go to the display options here, I can hide this layer. And I can freeze this layer also. And also if I go into layer properties, I can change its display from the option used in the viewport to an override. In this case, I'm going to say wireframe. And then I'm going to OK that. And now it's displayed as wireframe. And at the moment, our default layer is frame guide. In other words, any new objects that we create get put into frame guide automatically. But I actually want to put it back to default as the default layer. And now what I'm going to do is I'm just going to duplicate one of these cubes. I think it's probably a good idea just to start with this one here. So I'm going to hold on Shift and click on it, and that will duplicate it. And I just want it to be a copy. And I want to call it just frame. We'll change this to 0, 1 and say OK to that. Now I'm going to put it into a new layer, and I'm going to call this one frame. There we go. It's become the default layer, which is cool. As you can see, because the layer properties haven't been changed, the display of this object is snapped back to what the viewport is set up to be, which in this case is facets. So now what I can do is, for instance, I can freeze this frame guide, but actually makes it harder to see because of the color that it's actually shaded in. So let me just go through here and select all of these objects. Go to display properties, and there's an option that I want to change. And because some of these objects are in layer properties, I will have to do it here. And it's this option here, which is show frozen in gray. Now you saw that when we did that, the gray that it's using for freezing is very similar to the viewport background. I'm just going to turn that off and say OK. And now when I freeze, it should actually stay the same color. But the good thing is I can't actually select it. So now we have a nice guide that we can use, but we can't select. And if we go to the top viewport, you can see that it's visible there, perspective, front. I'm just going to turn off the grid in these views. And in the left viewport as well, you can see it's visible in all those views, but we can't actually select it. So it's a really good guide for us to work to. Something to note about this model is it's symmetrical. You can see there's a symmetry down the center point here. And that means that we don't have to model the entire frame to get an end result which is usable. We only have to model half of the frame. We just have to model one half down one side of the symmetry. And then we can use various methods to actually reproduce the other side just by mirroring that model across to create the other side. The easiest tool to use these days is a modifier called symmetry, which, as you can imagine, has been designed specifically to carry out this task. And what it does is it actually effectively cuts the object down a certain plane that you define. Then it mirrors the object based on that plane. And then it welds the vertices together. In other words, it attaches the vertices together so they become one along that plane of symmetry. So I'll show you what happens with this box here. And I'm just going to pull out the control panel here so we've got a bit more room. If I go to here, just make sure this isn't an instance. It's not. Go down to symmetry. And it's important it's not an instance, because otherwise when we applied this symmetry effect to this cube, it would actually do it to the same cube in the frame guide as well. You can see it's using X as the axis for the symmetry, which would actually be along here, and that isn't good for us. So I believe it's Y that we need. And now what I need is a modifier so I can actually start doing poly modeling on here. So I'm going to go down to box, and above box I'm going to put an edit poly modifier. Let's just check then what's going to happen here. In theory, if I can select these vertices, and if I move things around, what's actually happening there is we're not mirroring the right side of the model. So I need to go up to the symmetry modifier and say, instead of mirroring this side, mirror this side instead. So I'm just going to say flip. Now if I go back down here, move these vertices, there we go. So it's now actually mirroring along the right plane for us. So there we are, we're all set up. We've got our frame guide frozen in its own separate layer. We've got it set to wireframe, so it's not going to interfere with our view. And we've got an object with edit poly on it and symmetry, and we're ready to actually do some mesh modeling. the vast bulk of the modeling that we're going to do in this chapter is going to be using basically tools which were designed for doing subdivision modeling. But as I said earlier in this DVD, you don't necessarily have to use them for that. So I'm just going to select this edge here, go ring, which selects all the edges around in a ring, and then I'm going to connect them together and let's move the connection that we've just done. It wasn't visible there, and that's because it was past this, basically on the symmetry point right in the middle, but I knew it was there. And then I'm going to move it up here until it actually comes to this point here, and that's going to give us the basis for actually extruding out a new face here. So let me just zoom in on that, make sure that's looking good. Yeah. And then I'm just going to change this option here, which is currently set to zoom extents. If we just see the tooltips, I'm going to change it to zoom extent selected. There we are. And that means that when we press Z to zoom in, we're going to get a slightly better zoom action for this particular scenario. So now what I need to do is go to polygon mode and select that face there. And actually I'm going to do two at the same time here. I'm going to extrude two faces. So I'm going to just hold on Control, select this face. And then with the extrude tool, which you can see here, there are a couple of options. I can either do it interactively by holding, just clicking on the button there and then clicking on a face, extruding outwards that way. As you can see, that's perfectly fine. And then the other option is to click on the options window here, and you can do it with a spinner now instead. So you can actually put in exact values if you wanted to. You could put in 7, whatever. And then you've also got some options here for doing extrusions by group, by local normal, and by polygon. And we're not going to look at those right now, but they actually are very important. But let's just cancel that for now. I'll just do a manual extrusion outwards. There we are. And then what I'm going to do is I'm going to adjust these vertices by going into the front view and zooming in. I'm just going to move these up until they're in the right position. This is the piece of frame we're trying to match here. I think that's pretty good. Just move that until it's right there. And then the other one we need to move is this one here. We need to move these vertices down until they reach this point. And then at this point here, we're going to create a new piece of tubing later. So we need a subdivision of that at that point there. So into perspective view with P, then Z for zoom. Zoom in on those vertices we had selected. Go to the face selection. Remember we had the other face selected up there. So we'll just deselect, select this again. Go to extrude, extrude this outwards. That's pretty good. I'll extrude out further, down to here. Zoom in on that. Just go in there with some vertices. Yeah, it's not quite there, is it? Just pull it up here a bit. Go to extrude again. Then extrude again. Out to here. Into vertex mode. Select these vertices and zoom in. And that's not bad, but we'll just move it up a bit. And then inwards to here. There we go. These faces are still in alignment with the scene, so we can just carry on extruding like this. We know we're going to get pretty good results. I'll extrude this in towards the center till it joins up. So you can see it's a really fast way of working, very easy to do. You just need to put in the subdivisions where you need them, make minor adjustments, and very quickly you can build up quite a substantial model. Just select all these edges and connect them. Move this edge in here, select here. Just going to extrude that upwards. Now, I'm selecting the buttons here, but if you were doing this kind of modeling day in, day out, you might probably want to actually either find out what the keyboard shortcuts are, or if they don't exist, assign them yourself. Because, you know, if you're doing a lot of extrusion work, then there's no point in wasting your time moving your hand over to the button when you can just do so using a keyboard shortcut. So there we go, just move that in there. And I created that subdivision there, so later on we could have this pipe join up here. So there we are, we've created the bumper and we've created a large chunk of the actual geometry of the go-kart. So let's now put this in here towards the middle. That's that joined up. We need to do the back of the go-kart now, so let's do that. Just go here, screw it up here. Just doing this by in some cases, and in some cases it just works out that it's pretty much bang on. Don't really have to make any adjustments. And even though it's not completely accurate, we're not talking about a piece of CAD data here. This is just a model which has to look good, and therefore you don't have to have total accuracy. But it's working out to be pretty good here anyway. There we go. Oh yes, and also this pipe here. This is where the axle will be going through later on. And up here. Again, we need to leave some room for this bar here. Just be careful. There we are. Got that right. And in we go. That's great. See how quickly we modeled that? That's very, very quick, eh? Okay, so we've set a pretty blistering pace here, I think, and we've got the base part of the frame done. Let's go on now into the next chapter where we'll work on the top half of the frame and adding a lot of the sort of fiddly parts of the model.